Okay, here's our plans for the day. Here's what you missed last class. What I did is I took any questions over the worksheets that anybody had. I also gave your class a skill check over worksheet 1 and 2. I gave them this skill check because coming up you'll need to know this information because this was quiz review. So this was very important for you to know. And then I went over the difference between an arithmetic series and an arithmetic sequence, and I introduced sigma notation. We will add another formula to your worksheet today, or to your note card today. So keep up. I'll click right through this, take good notes, and then we'll go from there. First off, there are your answers to your worksheet number 2. At some point, take some time, look those over, and make sure that you understand those. I'll need to see this worksheet to make sure I give you any points for it. But here goes today's lesson. And what I've given you right here is called an arithmetic sequence. That's what we've been studying. The numbers 2, 7, 12, 17, 22, that's a sequence. In a sequence, they're separated by commas. But in an arithmetic series, what we do, the word series means I'm going to add the terms together. So a series looks like this: 2 plus 7 plus 12 plus 17 plus 22. One of your quiz questions coming up down the road is, what's the difference between a sequence and a series? And your answer needs to be, in a series, we add the terms. Okay, some notation that you'll see today. S sub 2 simply means this. I would like for you to go sum up the first 2 terms. So in this case, you'll say 2 plus 7 is 9. There's S sub 2. S sub 4 means, you probably guessed it, I'm hoping, sum up the first 4 terms. So 2 plus 7 plus 12 plus 17. And then that looks like 29, 31, 38. There would be that solution. Think of this real fast, then I'm going to show you how we're going to write it as mathematicians. Given the formula, b sub n equals 3n plus 1, I would like for you to find b sub 1, b sub 2, b sub 3, b sub 4, and b sub 5, and then add them together. So here's what you're going to be doing. B sub 1 is, and remember just for some quick review, to find the value of the first term, plug 1 in right here where the n is. So 3 times 1 is 3, plus 1 is 4. B sub 2 means plug in 2 right there. 3 times 2 is 6. 6 plus 1 is 7. B sub 3 would be then 3 times 3 is 9, plus 1 is 10. B sub 4 would be 13. B sub 5 would be 16. If I add all of these terms up, it looks like I'm going to get 50. Now here's what that exact same problem looks like in mathematical notation. I'm hoping that you recognize this symbol right here. That was our symbol sigma. Sigma means summation. It's the Greek letter sigma, means summation. Whenever you see that symbol, that means you're going to be adding up some terms. Here's this exact same problem mathematically. I'm going to say n equals 1 to 5 of 3n plus 1. Here's what this says mathematically. I would like for you to take all the numbers from 1 to 5, all the integers from 1 to 5. So you're going to use 1, 2, 3, 4, 5. You're going to go find the value of each of those. So just like we did over here. But here's how it looks now. 4 plus 7 plus 10 plus 13 plus 16. Add them up and get 50. So this right here, guys, is the same thing as all of that. This is mathematical. This really isn't. It's got math involved, but it doesn't look very fancy. So this should be in your notes. Some of these examples. I'm going to skip, well, I'm going to hit this one. These two should be in your notes. You also have this video you can go back on. But here's what it says. I'd like for you to go from 1 to 4 using the equation 5x minus 3. Whenever you see the word expand, what that means you're going to do is you're going to plug in 1, then 2, then 3, then 4. And then you're going to add those terms together. So this says go from 1, the first term, to the fourth term. The bottom number tells you where to start. The top number tells you where to end. So here's what I do, guys. I write down the numbers I'm using. 1, 2, 3, 4. You are now asked to plug in a 1. 5 times 1 is 5, minus 3 is 2. I'm going to write a plus sign because that's what this thing says to do, is add them together. Now plug in a 2. 5 times 2 is 10. 10 minus 3 is 7. Now plug in a 3, and you will get 12. Now plug in a 4, and you will get 17. And then use your mind, use your calculator, but add those together, and you would get 38. So that's what that means. Use the numbers 1 through 4. Run them through your equation. So really what are you doing? Finding v sub 1, v sub 2, v sub 3, and v sub 4, and then add those terms together. Here's what my next one looks like. We're going to sum up the terms from 1 to 4 of 2x plus 1. So I'm going to plug in a 1, a 2, a 3, a 4. If I plug in a 1, I'm going to get 3. When I plug in a 2, I'm going to get 5. When I plug in a 3, I'm going to get 7. When I plug in a 4, I'm going to get 9. Add those together, and you'll get 24. That's all there is to it. That's what I mean by expand. Of course, I got more examples for you. On this one, it may be a hassle, but here's what it would look like. I'm going to use the numbers 1 through 7. So I'm going to use a 1, a 2, a 3, a 4, 5, 6, and 7. I'm going to plug all of those in. So it's tedious, but I'm going to plug in a 1 and get a 6 times 1 is 6 minus 5 is 1. Plug in a 2, and then I'm going to get a 7. I'm going to plug in a 3, and I will get 13. When I plug in a 4, I'm going to get 19. When I plug in a 5, I'll get 25. When I plug in a 6, I'll get 31. And when I plug in a 7, I'm going to get 37. If you recognize this, if you graph this, that would be a line. Line with the slope is 6. I should be going up by 6 each time. So a lot of times you'll see a pattern. When you run those through your calculator, you'll get an answer of 133. Okay. Hopefully you're starting to get the hang of this. I'm going to try to trick you up just a little bit here on this one, though. Notice that this one says k equals 3 to 6. In this case, I do not care about term number 1, and I do not care about term number 2. But I would like for you to find term number 3, 4, 5, and 6, and then add them up. So once again, this time you're going to start with a 3. And be careful where you plug that in at. So I'm going to go 8 minus 2 times 3 and get 2 plus. I'm going to plug in a 4. That's going to give me 8 minus 2 times 4 gives me 0 plus. Now when I run a 5 through there, 8 minus 2 times 5 is negative 2. And then when I run a 6 through there, 8 minus 2 times 6 is negative 4. I'm okay in the math, so I'm doing these quickly in my head. If you need to pause the video and run the numbers through, feel free to do that. But when I add this up, I'm going to get negative 4 in this case. Because I notice my 2 and negative 2 cancel out. Okay. So that's how we handle those. Even on this one, before I move on, x equals 1 to 4, you're going to use a 1, a 2, a 3, a 4. When I run a 1 through there, 1 squared is 1, plus. Run a 2 through there, 2 squared is 4. Run a 3 through there, get 9. Run a 4 through there, and get 16. When I add that up, 16 and 4 is 20. 1 and 9 is another 10. So I know this comes out to be 30. Okay? That's what it is when it says expand. On your worksheet, you'll do numbers 1 through 6 just like this. Numbers 1 through 6 like those examples. Plug in your numbers, and then you'll add them up together. Now, I got a neat little story for you on this one, because going 1 through 4 terms, man, that's too dang easy for you guys. What I'd like to do is make it harder. I'd like to go maybe to 40, 100, 200, 1,000. I'd like to go to more terms. But here's a neat little story for you. True story. Little kid named Carl Gauss. He was 10 years old when this happened. The teacher gave this assignment. Class, I would like for you to add up the first 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add them up. When you're done there, turn around and add up the first 100 numbers. Well, before the teacher could get back to her seat, little Carl Gauss said, okay, teacher, when I summed up the first 10 numbers, I got 55. When I summed up the first 100 numbers, I got 5,050. Now, some stories say the teacher celebrated because Carl was such a genius. Other teachers said the teacher thought he was being a smart aleck, so she got on him a little bit. But here was his thinking. Now, remember, he did this all in his head at the age of 10 years old. But here was his thinking. He said, well, teacher wants me to add up the first 10 numbers. That's going 1 plus 2 plus 3 plus 4, hang with me, plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. That's the same thing as going 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4, 3, 2, 1. Here's why he did that. He saw this pattern. Notice what happens when he adds vertically. 1 and 10 is 11. 2 and 9 is 11. 8 and 3 is 11. Well, here's what he saw. He said, I've got 11 10 times. But since I wrote it twice, I got 2 of them, so I got to divide by 2. Well, 2 went into 10 5 times. 5 times 11 was 55. What's how he did the first 100, though? 1 plus 2 plus 3 plus all the way up to 100. He said, well, let me just switch that around. 100 plus 99 plus 98 plus all the way down to 1. Look at what he gets. He gets 101 every time we add vertically. So he's going to get 101 100 times. And he divided that by 2. And still doing all this in his head. 2 went into 100 50 times. So remember 50 for a second. I'm going to write down a 0. Now we got a 5 left. 5 times 101 is 5050. Let me clean that up. Let me move this 0 over a little bit. But that's how he did that. I'm going to try to turn this into a formula that we can use at any time, anywhere, to sum up a sequence. Look at the numbers that he got. He added up 1 and 10, 10 and 1. To get these 11s, he took the first term plus the last term. He took the first term plus the last term, whether it be 10, 20, 100. And then he multiplied that by the number of numbers that he had. Here's what I mean by the number of numbers. I was adding up 10 numbers, or I was adding up 100 numbers. And then every time, he divided that by 2. On the next screen, and then I'll pause for just a second. I usually don't pause on my videos, but you'll need to write this formula down. Here's a formula for arithmetic series. You already have this one on your note card from last time. If you will, put this one on your note card and title it Arithmetic Series. If you have to, you can pause the video and then continue it. But in this formula, S of n represents how many numbers I'm going to add up. 100 numbers, 1,000 numbers, 88 numbers, that doesn't matter. The number of numbers I'm going, A sub 1 and A sub whatever our last term is. To find A sub 1, I'm going to plug in 1. To find A sub n, I'm going to plug in whatever number we're working with. So plug in our last number. On the next screens, I have examples of these so you can see. Now, I'm going to click through the calculator part a little bit to save time on the video. But make sure that you write this example down. Write down the summation from 1 to 40 of 2x plus 3. Here's what this is going to look like. To sum up these first 40 terms. I know I'm summing up 40 terms because that's what that number right there tells me. It's going to look like this. I'm going to write it out on my first example, and then I'm going to speed the process up after this one. But here's what my formula says. It says S of n equal n over 2 times a sub 1 plus a sub n. That's what my formula says. Here's what it's going to look like using our numbers. The sum of these 40 terms will be, in this case, 40 over 2 times whatever a sub 1 is plus whatever a of 40 is. Remember, 40 terms. So watch what I do here. This becomes 40 over 2 times. To get the value of your first term, go plug in 1 into your formula. I'm going to come plug in a 1 right there. 2 times 1 is 2, plus 3 happens to be 5. That is a sub 1. Now I also need a sub 40. So I'm going to plug in 40 right there. That's how we find the first term, the second term, the third term, the 40th term. So 2 times 40 is 80. 80 plus 3 is 83. Now what you will need to do is make sure you can use your calculator correctly. Once again, hit pause on the video if you have to. But in your calculator, you're going to do this. 40 divided by 2 times parentheses. You got to have that parentheses. 5 plus 83, close your parentheses, equal. And if you do this correctly, you should get 1,760. That's what you should get. If you want to say, but Mr. Harris, I went 20 times 88. More power to you. You should get the same answer. Now, I'm going to speed it up on my next example. I'm going to go straight to this. I'm going to go straight to the numbers. But keep up with me. Pause the video if you have to. But after you see a couple with an open mind, you will understand how these work. Here's my next example. Take just a second to write that down. Hopefully you have it written down. Here's what it's going to look like. I'm going to sum up these first 75 terms. So I'm going to have 75 divided by 2. I now need a sub 1. So I'm going to plug a 1 right there where the x is. 3 times 1 minus 20 is negative 17. Plus. Now I need a sub 75. So I'm going to plug in 75 right there. 3 times 75 minus 20 is 205. When you run this through your calculator, 75 divided by 2 times parentheses, negative 17 plus 205, and you should get 7,050. That's what you should get. If you're not getting that, pause the video, type this in your calculator, make sure you get it. Here's my next example. Write it down if you think you need it, but otherwise watch what I do. I would like to sum up these first 300 terms. So it's going to look like this. I'm going to have 300 divided by 2 times. I now need a sub 1, so plug in a 1. 10 times 1 is 10, minus 450 is negative 440. Plus. Now plug in 300. 10 times 300 minus 450 is 2,550. Run this through your calculator correctly. and you should get 316500. There's my answer if I was to be mean one day and make you write out the first 300 terms and add them together. And yes, that would take a while. I've got a few more I'm going to click right through for you, but that's the process. That's what you need to do on your worksheet. On your worksheet, this is how you'll do numbers 6 through 10. That's as far as we got today, was problem 6 through 10. But I have a few more coming up, so I'm going to click right through them. Here's my next one. I'd like to sum up the first 50 terms of the sequence generated by 10 minus 7x. So it's going to look like this. I'm going to have 50 divided by 2 times, I need a sub 1. Be careful where you plug this in at. There's the x, so plug it in there. 10 minus 7 times 1 is 3. Plus. Now I need the 50th term, so plug in 50 right there. 10 minus 7 times 50 is negative 340. If you type this in your calculator correctly, you should get negative 8,425. Now you're thinking, wait a minute, that's negative. It's okay. If we started writing the numbers to this sequence, it would look like this. 3, negative 4, negative 11, negative 18, dot, dot, dot. Man, I got a lot of negative numbers. So if I add up all those negative numbers, I'm going to get a negative number. So it's okay to get a negative total. Here's my next example. Same thing. I'm going to pick the pace up though. To get this total, 100 divided by 2 times, plug in a 1, I'm going to get 19. Plug in a 100, and I'm going to get negative 575. So I'm going to put minus 575. Run that through my calculator. I got negative 27,800. Here's maybe one more. Sum up these 40 terms. 40 divided by 2. Plug in a 1, get a 5. Plug in a 40. 3 times 40 is 120 plus 2 is 122. Run that through your calculator. I got 2,540. Okay? That's your lesson. That's what we have done. On your worksheet, just once again, on 1 through 6, you're going to do it like we did at first. You're going to see things that look like this. N equal 1 to 5 of 2n plus 3. You don't get to use the main formula on that. What you'll have to do is plug in 1, 2, 3, 4, 5, and then add those numbers up. That's how you'll handle 1 through 6. 7 through 10, you're going to get to use our formula. So that's the lesson of the day. There are a couple extra slides on this, but I don't feel that we need them. That's the lesson for the day. So hopefully you swung by, you got your worksheet, get all caught back up. Good luck.